number 6. Let's take a look at this. Let's find the x and y intercepts for the equation, then graph the equation. Now on this, we're trying to find the x and y intercepts. I already got a little table of values up here for you. It says let x equal 0. What does let x equal 0 give you? That gives you the y-intercept. If you want to find the y-intercept, you let x equal 0. So when we do that, we get 3 times 0 plus 2y equals 12. Because what that does is when you plug in 0 for x, it eliminates the x values. So when you get rid of that, it gives you 2y equal to 12. Divide by 2, and y equals 6. So the y would equal 6. So my y-intercept is 0, 6, which would be right there. So to find the y-intercept, you plug in 0 for x, and your y-intercept will pop out. So guess what? When I plug in y equals 0, I get the x-intercept. So again, if I do that, 3x plus 2 times 0 equals 12. Now that zeroes out, and that gives you 3x equals 12. Divide by 3, and x equals 4. So x equals 4. So my x-intercept is 4, 0, which is right there. Once you get those 2 points, then you can draw a line through those 2 points and have your line drawn. That is one easy way to draw or graph an equation, is just find the x and y intercepts. It's pretty nice if they come out whole numbers. If they come out decimals, it makes it a little bit harder, but you can do it there too. Here's this graph the linear equation. Now the cool thing about this one is it's in slope-intercept form. And this is slope-intercept form, which is y equals mx plus b. What does the m stand for? Slope. What does the b stand for? The y-intercept. Now when you're graphing using the slope-intercept form, if you will start with the y-intercept, this is your starting point. You're going to start at that point. What is that point? In this case, it's a 1. That's where it crosses the y-axis at 1, right there. Now, what's the other part? The other part is the slope, 3/4. So we got 3/4. And this is rise over run. So that means I'm going to rise, go up 3 units because it's positive. 1, 2, 3. So I go up here 3 units, then run 4. So that means I'm going to go from that point, I'm going to run 1, 2, 3, 4. I'm going to run 4. 1, 2, 3, 4. Right there. So there's my newest point. I can do that as many times as I want. If I want to go up there and do it again, and go up 1, 2, 3, and over 1, 2, 3, 4, and make another point. I can do that forever until I feel like I can draw me a straight line through all those points. That's the quickest way to graph, is if you put it in slope-intercept form, graph the y-intercept, and then map out the slope. It goes really quick. Next, find the slope of the line going through the pair of points. There's the formula. Right? If you feel like, I'm not sure if it's on the final, it probably is, but if not, you might want to write that on your note card. So we got our change in y's. Remember, this goes x, y, x, y. Does it really matter which one's x of 1, y of 1, which one's x of 2, y of 2? No, it really doesn't. So if I take, let's say this is 1s, these are 2s. Okay, if I take my second one there, -2 minus a -3 over my x's, 4 minus 1. Double negative is a positive, so that makes -2 plus 3, which is 1. 4 minus 1, which is 3. So it'd be 1/3. Watch your positive and negatives. I saw a lot of people write it all in the formula correctly, but when you had all these negatives, -2 minus a -3, came out with the wrong answer on that part on the midterm. I did see a lot of that. So watch your signs. Be real careful there. Write the slope-intercept form of the equation. Now here's the cool thing about this. Right here, that's your slope. Remember m? Now, how do we find the y-intercept a while ago? We plugged what? 0 in for x, right? To find the y-intercept. Well, hey, look at this. What's my x value? 0. So guess what? That is my y-intercept. So when I plug this into y equals mx plus b, all I have to do is the slope is what? 3/5. And the y-intercept, b, is 6. And that's my final answer. They were nice enough to give me the actual y-intercept. Now, if they gave me a different point, then I would have to plug in a y value, the x value, and the slope and solve for b. Then once I solve for b, then I plug it back into the equation with the slope and the b, the y-intercept, and be done. And number 10 says find the equation of a line that contains the given pair of points. Write the equation in the form y equal mx plus b. Now, when you've got 2 points, what you need to do is, well, first find the slope. There's a hint right there. So I take my y value, 7 minus 2, over my x value, 0 minus 6. I get 5 over a negative 6. So my slope is negative 5/6. Now the cool thing here is, again, they gave me the y-intercept. So at that point, I could go y equals mx plus b. I know my slope, which is negative 5/6. And I know my y-intercept, which is 7. Now what I want to do is I want to show you what happens if, let's say they didn't give me that point. Maybe they gave me a different point that was on that line. We're going to solve it a different way. We're going to solve it using slope-intercept form, but this time instead of using the y-intercept, we're going to use the other point, 6, 2. So what we're going to do here is we're going to substitute x and y. We're going to substitute y is 2. The slope is negative 5/6, and x is 6. And we're going to solve for b. Now in this one we normally wouldn't have to do this, but I'm showing you just in case you get a problem where they do not give you the y-intercept and you're able to figure out how to do this. Now if you've got a scientific calculator, you can figure this out pretty quick. Negative 5/6 times 6. The 6's actually simplify out. So you get negative 5 plus b on this side, and the 2 still over here. Then we add 5 to both sides. And when we do, we get 7 equal to b. What is b? Our y-intercept. So at that point, we go back over here to y equals mx plus b. And we won't substitute y and x, and now we just substitute the slope, just like we did a while ago, 5/6x plus, what's b? b was 7, and there's our equation. Same exact equation that we got a minute ago using the y-intercept, but this time we used the other point. And so we'll see you at the next one.